Use the definition of the derivative and the function f of x equals x squared to fill out the table of values shown below. Let's take the first a value, -2, that first x value, and let's make a equal to -2 in the definition of the derivative. Now, our next step will be to find the very first top portion of the numerator, f of -2 plus h. Now, our function is the squaring function, so we'll just put -2 plus h into the squaring function. Let's put that in the right spot in the definition of the derivative. Let's also calculate f of -2 all over h. We can't plug in h equals 0 yet because there's an h in the denominator. So we'll work on the numerator and multiplying it all out and see if we can come up with any simplifications by doing so. So we're working on the simplifications. The 4 minus the 4 is a key step. The 4 minus the 4, of course, gives 0, so we're going to be able to cancel that away. And when we rewrite the numerator, -4h plus h squared has a common factor, and it is h. We are going to factor out the h in the numerator. The GCF is h. And that allows us to cancel with the h below, and we're in business. So we don't have a 0 in the denominator, and we can just plug in h is 0 at this point, leaving us with -4 plus 0, which is -4, and we've got it. This is the derivative of the function at -2. Let's put this result in the table. Now pause the video and try a is -1. Okay, so here is the solution for a is -1, and we just put it into the definition of the derivative formula, paying attention to finding f of -1 plus h first. Simplify -1 plus h squared, simplify -1 squared. For each of these results, you just put it into the definition of the derivative. We're looking to simplify the numerator, and 1 minus 1 is 0. Now go ahead and factor the numerator, pull out that h, cancel the h's, and rewrite the limit. Now we notice we can just simply plug in h equals 0, and this gives us our value of f prime of -1. Now let's add this result to the table. Now pause the video and do the remaining x values, x equals 0, x equals 1, and x equals 2. Okay, let's take a peek at these solutions. When x equals 0, f prime of 0 is 0. F prime of 1, it's 2. And f prime of 2 is 4. Now let's look at the graph of y equals x squared, and let's sketch into it these tangent lines. At x equals -2, we want to create a slope of -4. Let's go down 4 and right 1, and then sketch in that line. Now looking at -1, let's go to -1 and let's sketch in the slope of -2, which means go down 2 and right 1. And we sketch that in. Now we repeat this process for all of the points. Make a slope of 0 at x equals 0, make a slope of 2 at x equals 1, and finally make a slope of 4 at x equals 2. These are the tangent lines at those points. Back to this table we created. Now you might have noticed something about the table, and that is that f prime of x is following a pattern. And the pattern is that you take any of those x values and you multiply by 2 and you get the value of the slope. So we're seeing that the derivative is a function in itself. But how could we possibly get 2x without going through all of this work? And I'll show you. What we just need to do is take the limit as h goes to 0, and I'm just going to make a really subtle change. I'm going to turn the a into an x. Before we had f of a plus h, now we have f of x plus h minus f of x over h. So all I did was change the a's to x's, and I'm being more general, and we'll see where this goes. Just like before, we want to start with the value of f of x plus h. So that's x plus h quantity squared, and when you multiply it out, you get x squared plus 2xh plus h squared. Of course, f of x is just x squared. We use both of these to substitute back into the limit definition, and you have an x squared minus an x squared, which is excellent because that adds up to 0, and we clean up the expression a bit. Now we search for a way to factor the numerator, and sure enough we can pull the h out just like we did before as a GCF. So h comes to the outside, and then we can cancel the h's. After canceling h's, we notice we can just plug in h equals 0 into the function. So that's what we do, and we end up with 2x. But that is exactly what we got through the table as a pattern, and f prime of x is 2x. You can always find the derivative by using the limit definition of the derivative. Thanks for watching, and stay tuned for more great math videos.